Okay, so recapping the 4.1 notes, the middle of page 3 to the end of page 5. So looking at here, I think I started around number example 7, I believe. And what's happening here is that you're doing a product rule between x to the 5th with 7 minus 2x to the 6th power. So the best way to think about this, if I use a kind of a different color, we use orange, is that that's one function and that's another function. So think of this as f and think of this as g. And you got two things being multiplied, right? Y equals f times g. And remember, what's the derivative of product rule? F prime times g plus f times g prime. And by the way, in Schoology, let me just close this down. It's getting kind of annoying. Okay. In Schoology, on the front page, there's a little cheat sheet on derivative rules and formulas to memorize. And you'll see that product rule is actually described there. In fact, if I just show it to you really quickly. So I strongly suggest you print this, laminate it, do whatever you want, but this will be a good guide to have. So you can see product rules are described here, quotient rule, chain rules are already described, and a new thing we're going to talk about today, implicit differentiation. And then we're going to be adding more stuff throughout the next couple classes. In fact, this entire worksheet will have covered all of it by next with Tuesday. Or sorry, that entire cheat sheet. So anyway, going back to these notes here. So now we know our product rule, or product rule is going to be happening. What we want to do is take derivative f, which of course is easy. That's 5x4. So that's super, super easy right there. But then, and of course, leave it multiply to g. That's fine too. Then you have f, you keep alone. And then you got to take derivative g. The derivative g is going to be the fun part. 7 minus 2x raised to the 6th power. So that's going to involve a chain rule. We're going to move the 6 to the front, drop the exponent by 1, and multiply by the inside. And that's what you get over here. You get this kind of this nastiness, which you can clean up a little bit. And then you can do some simplifying if you wanted to. Personally, I'm fine at this point. I'm totally cool with that. But you could clean it up after that. So, question in the chat. What if that x5 was a random integer like 5? If it was a random integer like 5, yeah, that's a great question. What if I have like 5 times 7 minus 2x to the 6th power? You could do product rule if you want to. Then derivative 5 is 0, right? And that just goes away, that portion. And then 5 times 6, 7 minus 2x. Just do the derivative 5 like you usually do. And then times -2. You would do that. But really, you don't even need to waste your time with the product rule because the 5 just comes along for the ride because it's a constant. And you really just focus on this part right there. So you can do product rule if you want to. There's no harm, no foul. Just a little extra work, but you can really just focus on the 7 minus 2x to the 6th power and do your chain rule there and you're done. So if x to the 5th was replaced with a plain old 5, that's what the question, that was the question. And doesn't just do the chain rule at that point. For example 8, this is what we call a double chain. So in this case, you have sine as your outside function. So you take derivative sine, just cosine, and cosine x squared minus pi is an inside. So you leave the inside intact. Then you take the derivative of the cosine, that's in blue, and that's negative sine. But then you have another inside, the x squared minus pi. So you got to do another one right there. That's why it's called a chain rule. It's like a chain reaction, if that makes sense. So you have the cosine, cool. Then you got to do the inside. Then you got to do all this over here. Then you got to do all this over here. So it's like boom, 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 boom. It's a simple chain. And you guys are going to practice this later today. Example 9, you're going to practice as well. This is an AP style problem. Here you're given some information about f of 5, f prime 5, and some other stuff about g. And you're saying, okay, find the derivative 1/2 f of x times g of x. Well, all you have to do here is do a product rule. And then, of course, plug in 5 and evaluate. And that's all you're doing. and it comes out as an actual number that you work out. And I trust you guys can work this out. It wasn't working on the notes here, but I did in the video. And of course, next one is chain rule. So you got to do the derivative of the outside, so f prime g of x times g prime of x. And you can see in the derivative rules, that's exactly how I wrote it. F of g of x, if you have a composite function, you do derivative of that, that's f prime g of x, keep g of x intact, times the derivative of the inside, which is g of x, so times g prime of x. So it's very mechanical. That's what's happening here. And here we have a kind of an interesting one. That's g of x raised to the third power, move the 3 to the front, drop the exponent by 1, keep g of x intact with the multiply derivative of the inside, which is g prime of x, and then plug in 5. You work it out. Some notation bit. I don't really do this, but some people do. This right here just means g to x raised to the 4th power. If you see it around parentheses, it means a 4th derivative. I like to do this. I just do like 4 accent marks. Or I just tell you if I made a 4th derivative. I think that's just a little confusing, but some people do that. Keep in mind, if you have 1 over f to the x, then make it f to the x raised to -1. But it's different than this one. Remember, that means an inverse function, right? That's a totally different thing. We're going to do that, I believe, on Thursday. We're going to do derivatives of inverse functions. So keep that in mind there. What was I going to talk about next? So you work that out. Yeah, and then this one here is just more of a, just showing you how we got, why we have to be in radian mode when you do derivative of trig functions. Because if you were in degree mode and we're trying to graph in the calculator, the graph the derivative, you wouldn't see much of anything. So, and the things that this limit here, which we use in our derivation of the derivative of sine x or of trig functions, assumes that h is in radians. So that's the reason why we keep things in radian mode when we do derivative of trig functions. And that was just a second derivative, just so you know. That's doing a derivative twice. So that's a simple recap of the notes. Now, the homework. I told you guys in school J to ignore what U is and just kind of just do it like the way we did it in class. Like, so if you look at my hints, from last week, homework 17 is right here. Yeah, I said ignore the instruction for substitution and whatever U equals, just do the chain rule using the following methodology, derivative the outside function with the inside kept intact times derivative the inside function. And of course, 81 was like a review problem. I don't actually, I do have the answers. So let me actually get my my textbook right here. And let me give you guys just the answers really quickly. And then you guys just tell me what you want me to review. And I'll do it. And then we will do some group work. So let me pull it up here. Give me 1 second. Okay. I'll do this in red, the answers. So the answer for number 1 is 3 cos 3x plus 1. By the way, all the odds are in the back of the textbook. I'll do my best to display answers for future homeworks. Number 2 was -5 times cosine of 7 minus 5x. And if you want to start asking questions in the chat about certain problems, please do so. And I'll tackle those questions after I finish writing these out. For number 3, the answer is, where the heck is number 3? I could just do it for you guys. Okay, I'll just do it. The answer for number 3 is just √3, negative √3 times sine of √3x. √3 times x, mind you. Number 4, oh, you gotta be kidding me. Oh, okay, it's somewhere else. Okay, so it's hard to locate spot. 2 minus 3x squared times secant squared, because that's root of tangent, right? 2x minus x cubed. Number 5 is sine of x squared plus 1 over 7x. I think things cancel out as a result, is my guess here. Oh, I'm looking at the wrong place. My bad. That made no sense. I was like, wait, how the heck do you get that? Where does a 7 come from? My apologies. For number 5, again, the answer is going to be 2 sine x. There we go. That sounds a lot better. 2 sine x over 1 plus cos x squared. And number 6 is 10 over x squared times cosecant squared over x. And number 7 is negative sine of sine x. So sine x is like the inside. Gosh, these x's are hard with the mouse. A little better. Times cos x. Okay. And I'll do number 9 with the heck. No, I need space. So so those are 1, 2, 3, 4, 5, 6, 7. Those are all the answers. So 1 through 7 all, obviously. So those are the answers. Now let me tackle your questions. So the first question that's being asked, could you please explain 920? Okay, I'll get there in a little bit. Next is 81. I'll do that as well. Okay, number 3 and number 3. Oh, wait. No, we're okay. Let's see here. So we'll explain number 3 and number 5. Okay, good. So 3, 5. Let me explain 3, 5 in a little more detail. Okay, I see the problem with number 3. Okay. Here's the deal with number 3. Only 3 is being square rooted, not the x. So root 3 is a coefficient. That's a little confusing there. Only the root 3 is being square rooted. So really, it's just cosine of x times root 3. Think of it that way. I believe that's really all that's happening there. Let me check the back. Yeah, that's right. Yeah, that's right. So then you just do derivative cosine, which is negative sine. Keep the inside intact. And then you have the derivative of x times root 3. And that's just a constant, right, being multiplied to x. So it's negative sine x root 3 times root 3. And that's your answer for that one. That's all. So that's number 3. For number 5, okay, that one's a little crazy. Yeah, so don't do anything special like square root when you're doing your derivative, because x is not being square rooted. Now for number 5, that's going to be chain rule first. You put the 2 to the front. So even if you're dividing two things, you're still going to do the chain rule, because overall the fraction is being squared. So if the fraction is being squared or something's being done to the fraction, you got to do the chain rule first. It's kind of like order of operations if you want to think of it that way. So you have that raised to the 1 power. I'll do a little 1 kind of like that. And then you got to do the derivative of the inside, sine x of 1 plus cos x. And that's a quotient rule. So this is a problem within a problem. The beauty about calculus is that everything builds upon itself, right? So you have to know quotient rule, in order to do this stuff. So by the time we get to deeper with the stuff, all the stuff seems second nature because you do this over and over again. Calculus has that natural progression, which is why it's one of my favorite classes to teach. So again, you have 2 sine x, 1 plus cos x, and I'll do this in say green. Then I do the derivative of this bad boy here. Remember, low D high, so that's cos x times 1 plus cos x minus sine x times derivative 1 plus cos x, which is 0 minus sine x, all over sine x, all over 1 plus cos x squared. Now, when you clean up the top, here's what's going to happen. All this becomes another problem within itself, which actually I'll kind of do over here in, say, burgundy. We'll say you do cosine x plus cosine squared x. And there's a lot of negatives. It's a negative sine x times a negative sine x is plus sine squared x. And we know that all this is 1. So this giant fraction, I can just sort of just cross that off and call it 1 plus cos x, which clearly crosses off over here, or the 1 plus cos x down below, and you get 2 sine x or 1 plus cos x squared. So that's how that's done. There's a new question in the chat. 29, okay, great. So that's 3 and 5. Let's do 9 and 29 because those have been asked, and 81 as well. Then after that, then I want to give you guys a chance to go to a breakout session. Okay, clear my screen. Let me give you guys the answers for all these here, and then I'll work out 9, 29, 81. So the answer for number 9 is, oh goodness, oh there it is, 3 sine. I'll just work it out. So S prime, they're using S instead of Y, whoop-de-doo, not a big deal. S prime equals derivative of cosine, which is negative sine. Keep the inside intact, times derivative of the inside. Derivative of the inside is negative 3. And you're all done. That's it. I mean, of course, negative 3 times a negative, it makes it a positive. So final answer could be like 3 sine of pi over 2 minus 3t. By the way, remember, you could always verify your work by going to your calculator. So let me pull up the calculator right now. So TI, excuse me. Here we go. Let's take a little time. Yeah, remember, you just type in your function, and then for y2, you do d dx of y1, x equals x. And of course, whatever you get by hand, put as y3. Y2 and y3 should be identical. This one involves a log, actually, and we're actually going to do that next Tuesday, those kind of derivatives. So remember, you can always verify your calculator by putting the original expression as y1, y2 do the end derivative, and y3, where you get by hand for the derivative, put that in as well. Y2 and y3 should match up. Okay, let me do 29, then I'll put the answer for 15, 16, 21 in just a bit. Someone asked about 29 for me to work that out. We'll use, I think that's pink. So that means second derivative, just so you know. So it means you got to do the derivative twice. Well, the first derivative is easy. We already know that. It's one of your rules. Y prime is just secant squared x. Or secant x raised to the second power. Easy peasy, right? Then you got to do it again. Another derivative. So you move the 2 to the front, keep secant x intact, drop the exponent by 1, so that becomes raised to the 1 power, and then times derivative of the inside. Times derivative of secant x. And we have, remember, our rules. So don't worry if you don't have these memorized, that's okay. Boom, there we go. You got it. Secant x, tan x, that's it. So it's just, this is our final answer. 2 secant x times secant x times tan x. All that in orange became all this right here. So it's 2 secant squared x, if you want to simplify it just a tad, times tan x. There you go. And that's all you got to do for 29. Now for 15, 16, and 21, 15, that was kind of crazy. We'll do that in red. That's -5 sine -6 raised to the x power times cosine x. And then you do the second part, -3, well, actually, it's going to be a positive, because I guess you got to do the derivative of cosine, which is negative, sine x, cosine squared x times sine x. For 16, where is 16? Oh boy. Okay. 16 is going to look like this. That's going to be 8x cubed, 2x minus 5 raised to the third power, plus 3x squared, because that's the root of x cubed, right? And you keep the other part intact. 2x minus 5 raised to the 4th power. And you can leave it like that. That's totally fine. Remember, the 4 went to the front, dropped exponent by 1, then you did your chain rule. That's how you got the 8x. Cube there, yeah. If you want to simplify it further, you could have pulled out a 2x minus 5 cubed and an x squared, I believe. And then in brackets, you would have 14x minus 15. If you wanted to go further, you could have done that too. Either answer is totally fine. And for 21, the answer for 21 was the following. 6, the book gets kind of cute on you here. 6 sine 3x minus 2 times cosine 3x minus 2. So you're doing a double chain rule in that case. The book decides to do a double angle formula. Don't waste your time with that. Just leave it like that. Now, if you have problems with 15, 16, and 21, hold on to your questions. When we go in the breakout sessions, I'll come join your room because you're going to do problems just like this in the breakout session. So if you have questions, hold on to that, because in the interest of time, I do need to make sure we have time for some breakout sessions and to do a little bit of the 4-2 notes. Yeah, so if you have a question about 20, I'll come join your breakout room and I'll help you out that one, because that's going to be similar to one of the breakout questions. Finally, for 81, here's the answer for that one. A bit backwards from chapter 3. Where the heck is it? 81. Might be in the back of the textbook, or maybe on the following page. Yeah, let me do that really quickly. Hopefully it's in the back of the textbook. Almost there, guys. Cool. The derivative is easy. You should have no problem. Oh, that's velocity. Velocity is the derivative of x prime. We know this, right? That's just 3t squared minus 12. Super easy. Then the acceleration is the derivative of velocity. So you have the second derivative now of the position function, or v prime of t. I don't care how you write that. That's just going to be 6t straight up. The particle's at rest when your velocity is 0. So you set your velocity equal to 0. That'll happen at t equals 2, or -2. We can't have a negative time, so you just say t equals 2. The speed, when acceleration is 0, well, acceleration is 0 at t equals 0. So your velocity at 0 is going to be -12, but it has to be absolute value for speed, so it's just 12. And we don't give units, so don't worry about units. And finally, for e, is the particle moving toward the origin or away from the origin at t equals 3? Well, v of 3 if you work that out, we do need our velocity, which is 27 minus 12 or 15. And a of 3, the acceleration, 6 times 3 is 18. Actually, you don't need to know the acceleration because we're not being asked about speeding up or slowing down. All you need to know is velocity. The velocity is positive, so it means you're going away. Because the particle moves along the x-axis at this time. So what we expect the positive velocity to be going away from your original position. So it's a positive value. So you're going away from the origin. Oh, wait one sec. Oh my God. Sorry. I told you guys wrong stuff. Okay, let's backtrack a little bit. Okay, first of all, where the heck is the particle? Where the heck is it? What is the position? My bad. Let's do x of 3. That's 27 minus 36 plus 5, which is negative 4. Okay, so right to the left of the origin. So you have a coordinate plane here, right? So right now, there's a particle. And your positive velocity, your velocity is positive, so you're going towards the origin. There you go. That's the answer, E. My bad. Okay. Oh, they are on the next page. Well, I worked it out anyway. Someone asked me to work it out. So there we go. Okay. Okay. So anyway, that covers homework number 17 review. Google form really quickly. Yeah, describe the chain rule. Remember, the derivative of the outside kept inside intact times derivative of the inside. Now, what you could do for number 2, for sine x over cos x, you could write as sine x times cos x raised to -1 power. It's the same thing as sine x over cos x. And then do a product rule with the chain rule, where you do derivative sine times cosine raised to -1 power kept intact, and then flip it. So that is very, very similar to what we saw for kind of like 21 a little bit. Not really, but you know, it's just a product rule. That's what's happening there with a chain rule for the cosine x part. Here, the answer is actually going to be -60. So if you look at the 4-1 notes, so g of x. So if we do that one, oh, I had to give you a number for x too. I should have said g of 5. Wow, I can't believe I did that. Ugh, my apologies. So I'm asking you to find g of 5. Well, first let's do that derivative. So that's going to be g prime of g of x times g prime of x. And then if I plug in 5, so g prime of g of 5 times g of 5. Well, g of 5, I believe you know, is 7, and g prime of 5 is 10. So g of 5 is 7. So you have g prime is 7 times 7. And then g prime of, sorry, g of 5. Is that right? Okay. And then g prime of 7 is -6. Yeah, my bad. I wasn't very clear in my instructions, so I kind of messed that one up. So the answer should actually be -42 for that one. Yeah, my bad. I should have put a 5 there. Let me actually update that for the other students. So x equals 5. Yeah. So sorry about that. And then finally, yeah. So basically, it's you're kind of assuming when you do that limit part, h is in radians, and you have to use that to do the derivation of the derivative sine x. So that's why we're in radian mode. Yes, and actually, you guys know I have good taste. We cooked Fred steak, so that's actually one of my favorite steaks. It's very expensive, but it's worth every once in a while. My son, I don't think would like scallops and cream crab legs, even though I do, but that's extremely expensive. And that's a special taste. I love hamburgers, hot dogs too, but not quite the season for that right now. But you know, I could always go for hamburger, hot dog at any time. Okay, cool. So let's go to the breakout session. So were you guys gonna do the breakout session? We'll do it actually for 15 minutes in the interest of time. And what I'll do is I'll work it out as well, and then share the answers in Schoology. So I'll take a picture of it so you guys have it. But yeah, let me show you what you guys are going to work on. So it's right here. It's called Chain Rule Practice, Tuesday, November 10th. So you're going to be working on 17 and 22, as well as 58 F and G. So I'll put you guys in rooms of like maybe 3 people so you guys can talk to each other and work and help each other. Call me over if you get stuck. I know one of you had a question that was kind of close to 22, so I'll come into the room and help you guys out. But this is what the quiz is going to be like. It's going to be like probably more like either 17 or 22, one question like that, and a question like 58, either F or G. So you guys are going to get a little practice there. If you go to Schoology, all you have to do is click on Unit 3 folder, week 11, and you should see it right there, Chain Rule Practice. So let's do the breakout session right now. I'll stop this recording.